So, very good morning to all my dear 11th standard students. Today we will start the pending portion of chemical bonding. In regular classes we have started chemical bonding, you know very well, but we could not finish it because of pandemic, as you know better. So right now via online method we will start our pending portion for the chemical bonding. So without wasting moment, our first task, what is that? That is the VSEPR theory. Okay, which theory? VSEPR theory. So I am writing here, all of you see carefully, VSEPR, very important theory from chemical bonding, or you can say from the branch of inorganic chemistry. The full form of this abbreviation is that valence shell electron pair repulsion theory. Okay, valence shell pair repulsion theory, VSEPR. Okay, now see here, directly we come to the consequences, or what is meant by valence, what is meant by VSEPR theory. Okay, this theory was discovered by or given by this theory was discovered by Sidgwick. Okay, Sidgwick. What is the main motive of this theory? Okay, so this theory is useful. See here. So here we will start a new theory. What is that? VSEPR, valence shell electron pair repulsion theory. Okay, now this theory was discovered by scientist Sidgwick. Okay, according to this theory, or this theory helps us to predict what? Predict the shape of covalent molecule. Which molecule? Covalent molecule. According to VSEPR, what happened? According to VSEPR, the atoms in the molecules are arranged in such a way that, okay, according to VSEPR theory, the atoms in the molecule are arranged in such a way that they will have minimum repulsion. Okay, what they have? They will have minimum repulsion. Okay, so that's why whenever there is a formation of molecule, atoms are arrange themselves in such a way that there is a minimum repulsion, and that's why there is a least energy and maximum stability. Okay, everybody know we want stability. In that way, non-living things also want the stability. Okay, and that's why what happened? Whatever atoms, in that atom there are the shells. In that shell there is a pair of electrons, so there is a repulsion in between the electrons. Okay, that's why that electrons are arranged themselves in such a way that there is a minimum repulsion. Okay, and hence we get proper shape. We get what? We get proper shape, and that is the main utility of the VSEPR. Okay, that is the main utility of VSEPR. Okay, now see here. So what happened? As electron pairs are arranged according to exhibit minimum energy, whatever shape we get because of them, that is nothing but the shape of that covalent molecule or geometry of that covalent molecule. Okay, now see here, it doesn't mean that only lone pair or bond pair. Before going to explain, you should know that there are two type of electron pairs. Which one? Lone pair as well as bond pair. See here, lone pair, in short we can write lone pair. And what about bond pair? Bond pair will be written as BP. Okay, so what is the way of means what we can say, what is the ease, what is the order of the repulsion between them? Then it will be found that lone pair lone pair has maximum repulsion as compared to lone pair bond pair. Okay, lone pair has maximum repulsion as compared to lone pair bond pair, which is further more than what? Bond pair and bond pair. And therefore you should remember that the repulsion between the lone pair and lone pair is maximum as compared to lone pair and bond pair as compared to bond pair and bond pair. Okay, so this is about the valence shell electron pair repulsion theory. In incoming days we will see in detail the exact application and proper consequences of the VSEPR. Here just it is introduction for you. Okay, after that we will switch on next theory. What is that? VBT. See here, VBT. What is meant by VBT? VBT is nothing but what? Valence bond theory. What is VBT? Valence bond theory. Now see here, the founder of this theory, okay, who is the founder? Hitler. Okay, Hitler in 1926 have discovered or put forth this theory, valence bond theory, and further Pauling and Slater. See here, further Pauling and Slater explained the same theory, that is what? VBT, in the year 1931. In the year what? 1931. So in examination there will be a question. Write a short note on VBT. What are the postulates of VBT for 2 or 3 mark purpose? So listen here everybody, VBT means what? VBT is nothing but the valence bond theory. So this theory is totally related to the formation of bond, how bond is formed. Okay, whether it is divalent molecule, trivalent molecule, covalent molecule, especially we are discussing here the formation of covalent molecule. Okay, so VBT was founded by or discovered by or put forth by Hitler in 1926, and further it is extended by scientists Pauling and Slater in the year 1931. So what happens? See here, already I told you that whenever there is a formation of covalent bond, we need 2 electrons. Okay, what we need? We need 2 electrons. For example, see here, suppose this is your one of the orbital which contain unpaired electron, it is your another orbital which contain one more unpaired electron. So this is nothing but the necessary and sufficient condition to form a covalent bond. Okay, this is the necessary and sufficient condition for the formation of covalent bond. So what happened? In order to form a covalent bond, 2 atomic orbital of different atom, okay, 2 atomic orbital of different atom must overlap with each other, we are discussing the postulates. Okay, must overlap with each other, and they should exhibit a single electron with opposite spin. They should exhibit what? Single electron with the opposite spin. For example, see here, this is your single electron which is observing in the upward direction, and this is your another single electron which is in the downward direction. So this is called as the what? This is called as single electron overlapping with opposite spin. Now what happened? When they overlap with each other like this, then what will happen? See here, then there is a neutralization of the spin. Actually what happened? There is a neutralization of spin, and this neutralization of spin is according to, or we can say the neutralization of this spin exhibit what? Release of energy, and hence that system becomes less energetic. How it become? It become less energetic, and hence it has a maximum stability. So what happens here? In order to form a strong covalent bond, what we need? We need minimum amount of energy, as it is happening because of the neutralization of the spin which occur due to what? Overlapping of 2 atomic orbitals. And once they combine with each other, what will happen? See here, once they combine or overlap with each other, what happened? Each atomic orbital have nuclei, and that nuclei clump come close to each other, and as a result of that, what happened? The electron density increases, and therefore force of repulsion decreases. Yes or no? In short, what can we say? In short, we can say that as force of repulsion decreases, there is an increase in the force of attraction, and hence there is a strong chemical bonding. Okay, so in this way there is a formation of covalent bond. After that, see here. So what is the necessary and sufficient condition? I repeat, the two atomic orbital overlapping together must exhibit single electron or unpaired electron with opposite spin. After pairing, after overlapping, that spin gets neutralized, and as a result of that, the system release the energy. Okay, and that's why stability is achieved, and we get the formation of strong covalent bond. After that, see here, in next postulate, the formation of covalent bond takes place at an equilibrium distance. This is very important. Okay, at an equilibrium distance, and at this point, at this distance, what happened? System exhibit less energy. Okay, potential energy is very less, and stability is maximum. Stability is maximum. Understood? So in this way we can explain that. Okay, now everybody know the atomic orbital except s orbital. Okay, atomic orbital except s orbital are directional in nature. Yes or no? Due to that fact, what happened? Whenever there is a formation of covalent bond by the atomic orbitals, they have directional properties in the space. It is due to what? It is due to the directional nature of the orbitals except s orbital. P has some direction, D has some direction. Okay, so that's why there is a proper orientation of that atomic orbital in the space, and hence they provide the particular shape or geometry to the molecule. Okay, now see here. Now come to this diagram. When there is overlapping, okay, when there is overlapping between, now come to this diagram. When there is a overlapping between the two atomic orbitals, what happens? See here. If the extent of overlapping is greater, okay, there are two type of overlapping with greater extent and overlapping with the poor extent. Okay, so when there is a overlapping with what? Greater extent, then chances of formation of strong covalent bond will be there. Chances of formation of what? Strong covalent bond will be there, and hence what happened? Strong formation of covalent bond favored the greater extent of overlapping. So in this way, what happened? See here, we have seen the postulates of valence bond theory. So you got here how covalent bond is formed via atomic orbitals, how there is a directional characteristics for the particular formed covalent molecule or covalent bond. It is just the directional orientation of the orbital of the atom in the space except the s orbital. Now here, see here, we discuss one question. See here, it is very important. What are the interacting forces and changes in energy? Okay, what are the interacting forces and changes in the energy during the formation of covalent bond? Which bond? Covalent bond. Now see here, it's very simple. Okay, now here we have to discuss what type of forces comes to play and what about the changes occur during in the energy during the formation of covalent bond. Okay, now see here what happened. See here, when two atomic orbital come close to each other for overlapping purpose. Okay, when two atomic orbital come close to each other for overlapping purpose, then what happened? There are two type of forces. How many type of forces? Two type of forces. See here, for example, we have first nuclei. Okay, this is your first nuclei, exactly, first nuclei, and this is your second nuclei. Okay, now see here, this is your first nuclei, and it is your second nuclei. Okay, now suppose there is an electron, again there is an electron, again there is an electron, and again there is an electron. Now what happened? Number one, see here. When such a atomic orbital come close to each other, indirectly two nuclei come to each other. At that time, first force come to play. What is that? Force of repulsion. Okay, force of repulsion. So there will be a force of repulsion between what? There will be a force of repulsion between the electron of first nuclei and electron of second nuclei. So we can show in this way. Okay, there is a force of repulsion between what? Electron of first nuclei with that electron of second nuclei, and that's why they are going away from each other. After that, again we can write there is a force of repulsion in between what? Electron of first nuclei and electron of second nuclei. Okay, again there is a force of repulsion between what? Force of repulsion between what? The nuclei of first model with the nuclei of the second model, or you can say atom. So in this way, see here, electron repulsion we can say, exactly, electron repulsion. Again, nuclei which is exhibited or shown by the positive charge and positive charge of the other atom, there is again what? Repulsion. There is again what? Repulsion. Understood? Now let us discuss about the second force which comes to play. What is that? Force of attraction. Force of attraction. Okay, now comes to the diagram again. What happened? The electron of first atom is attracted by the nuclei of the second. Exactly, yes or no? Electron of the first atom is attracted by the nuclei of the second atom. Similarly, electron it is attracted by this, yes or no? So it is attraction, it is repulsion, it is attraction, it is again repulsion. Okay, so in this way we can have the diagram. So here we can write forces during the formation of what? Covalent bond. Formation of covalent bond. So everybody see here, force of attraction is between what? Electron of first nuclei, first atom with that nucleus of second atom, or nucleus of first atom with the electron of the second atom. So in this way there is a force of attraction, force of repulsion, and force of repulsion. Now this is simple idea, you know very well. Like charges repel each other, yes or no, and opposite charges attract each other. That is thing, positive repulsion, negative repulsion, positive attraction, negative attraction. By that rule this is confirmed or this is true. Okay, now what happens? See here, now we have to discuss about the changes in the energy during the formation of covalent bond. So what happened? There are two forces. Which one? Force of attraction, force of repulsion. Now what happened? When the magnitude of force of attraction, see here, when the magnitude of force of attraction is greater than the magnitude of force of repulsion, then there is a formation of, see here, whenever there is a greater of magnitude of attraction as compared to the magnitude of repulsion, then there is a formation of strong covalent bond. Remember this, okay? Strong covalent bond. It means that there is a minimization of energy and hence more is the stability. And when the magnitude of repulsion, okay, the magnitude of force of repulsion is greater than the magnitude of force of attraction, then there is a formation of weak covalent bond, we can say, weak covalent bond. In this case what happened? Energy is greater and that's why stability is lesser. And here in the first case where attraction is greater than the repulsion, what happened? Here there is a less energy, more stability, more energy, less stability. So these are the forces and changes in the energy during the formation of covalent bond. Okay, now see here. Here we will discuss the types of covalent bond. Okay, now see here, we will discuss the types of covalent bond along with their formation, along with the proper example. Now see here, covalent bond. Okay, so there are two type of covalent bond. See carefully, it's very easy. Number one, number two. Okay, first one is the sigma bond, which is denoted by symbol. Okay, and second one is the pi bond. Which bond? Pi bond, which is denoted by the symbol pi. Okay, now see here, let us define sigma bond and pi bond. So what happens? Sigma bond is formed as a result of face to face overlapping, that is called what? Axial overlapping. Which overlapping? Axial overlapping. Understood? Okay, so what happened? Sigma bond is formed as a result of axial overlapping, that is also called as what? Face to face. Okay, face to face overlapping. On the other hand, pi bond is formed as a result of lateral or sidewise overlapping. Which one? Lateral or sidewise overlapping. Understood? Okay, so this is the main difference. After that, sigma bond is formed as a result of SS overlap, number one. After that, SP overlap, and after that there is a PP overlap. It means what? When two s atomic orbital of two different atom overlap, there can be a formation of sigma bond. When one s orbital and one p orbital of two different atom overlap in this way axially, then there is a formation of this similar to PP. But what happened? This pi bond is only formed as a result of lateral or sidewise overlapping of p and p atomic orbital of the two atoms. Okay, now see here, one by one let us discuss them. See here, there is a question, explain the formation of SS overlap. Okay, explain the formation of SS overlap with suitable example. Now see here, the best example is the formation of H2 molecule. See here, after that we will start the hybridization. In that you will get exact idea how there is overlapping. But before that we should know SS overlap means what are their example, SP overlap means what are their example, and PP overlap means what and what are their examples. So formation of H2 molecule. So before that already we have studied how to write the electronic configuration of hydrogen. Okay, so 1s1 is the electronic configuration of hydrogen. Okay, 1s1 is the electronic configuration of hydrogen. In this way we have two hydrogen here which combine together to form the H2 molecule. So 1H, that is 1s1, and here 1H, what is that? Here 1s1. Now everybody know s orbital is circular in nature. Yes or no? It has a circular shape like this, X and Y we can say. Okay, after that see here, in this way we can write X and Y. Now both contain one electron. So as a result of that, what happens here? There is such a type of axial overlapping. Okay, and here there is one electron for the 1s of this hydrogen and one electron for 1s of this hydrogen, and in this way there is overlapping. Now this type of overlapping is called as axial overlapping. Okay, axial overlapping. Actually what happens, see here, okay, the overlapping for the formation of sigma bond is along with the internuclear axis. And in this way there is a formation of sigma bond. Sigma bond, which is found to be a very, very strong covalent bond. Okay, strong covalent bond. Now see here, let us back to the point how to explain the sp overlap. Okay, now for SS we have taken the example of hydrogen molecule, as you know very well. Now see here. Then number 2, same question, explain the overlapping of sp. Okay, explain the overlapping of sp. Now see here, for that we will select HF molecule. Okay, which molecule? Hydrogen fluoride molecule. Now hydrogen, we know what is the electronic configuration, 1s1 exactly. What is fluorine? We know atomic number is 9, so its electronic configuration will be 1s2, 2s2 and 2p5. Okay, now in detail if you write, how will you write? 1s2, 2s2, so 2px2, 2py2 and 2pz1. Now see here what happened. Everybody know what is the condition according to VBT? The overlapping atomic orbital must contain unpaired electron with opposite spin. Therefore this 1s1 of hydrogen and 2pz1 of fluorine axially overlap with each other in this way. See here, axially overlap with each other in this way, x, y, exactly. What is this? Your 1s, now 2pz, see here. Okay, this is your 2px, this is your 2py and this is your 2pz, exactly. So there is a axial overlapping between these two and there is a formation of what? Yes, there is a formation of such a type of interaction will be there. See here, this is your 1s which contain 1 electron, this is your what? 2pz, there is a another. So in this way there is a formation of pair of electron which do form a strong sigma covalent bond. Okay, which do form what? Strong sigma covalent bond as a result of sp overlap. As a result of what? Sp overlap. Again overlapping is along the internuclear axis. Okay, similar to that we can have number 3rd, what is that? PP overlap. Okay, what is that? PP overlap. So let us write here PP overlapping. Okay, so very easy to understand, don't be panic. PP overlap. So see here, PP overlap. For this we will take which molecule? F2 molecule, let us say. Okay, F2 molecule. Now F, already we have discussed F. What is F? 1s2, 2s2 and 2p x2, 2py2 and 2pz2. Is that clear? Sorry, 2pz1. So everybody see here. So the drama will be like this. Okay, okay and okay. So it is 2px, 2pz and 2py of first fluorine. Similar to that, 2px, 2py and here 2pz. Okay, so see here, 2pz contain 1 electron, here 2pz contain 1 electron. So similarly they overlap in this way. Just a minute. Overlap in this way, single electron, 2pz1, here single electron with opposite spin, 2pz1. Okay, first fluorine and this is your second fluorine. As a result, how they overlap? See here, in this way they overlap. Okay, and there is a, we can say, overlapping of PP, overlapping of PP. Okay, and hence there is a formation of SS, SP and PP overlap. They exhibit formation of covalent bond. Now let us differentiate between the sigma bond and pi bond. Okay, in examination questions will be there. How will you distinguish? How will you distinguish sigma bond and pi bond? So everybody see here. Sigma bond is formed as a result of axial overlapping. Pi bond is formed as a result of lateral or sidewise overlapping. Okay. Now axial overlapping is always, or we can say formation of sigma bond take place always along with the internuclear axis, and formation of pi bond always take place around the internuclear axis, around the internuclear axis. After that, bond enthalpy of sigma bond is very strong. Bond enthalpy means what? Bond energy. Bond energy of sigma bond is very high, you can say, as compared to the pi bond, as compared to what? Pi bond. After that, see here, Sigma bond can be formed as a result of SS overlapping, SP overlapping, PP overlapping, but pi bond will be formed only as a result of PP overlapping. Okay, only as a result of what? PP overlapping. So dear aspirant, in next video we will see a very important topic. What is that? Hybridization. Don't miss that topic because it will change the history of your chemistry. In fact, I will say for 12th standard purpose, the chemical bonding chapter, each and every content of this chapter is very, very important. Okay, so in next video we will cover hybridization right from the basic fundamentals. Okay, thank you.